So I had started example 1 in a different video, and I just want to take a few seconds here to wrap it up. The last problem had a cube root of x, and it's very similar to the square root of x problem that came before it. You just have to rewrite the radical with an exponent that is a fraction, 1/3, then move the fraction 1/3 to the front, then subtract 1, and so on and so forth. So hopefully you got the right numbers and you got the right answers. So it turns out to be that either one of these three is perfectly fine and acceptable as a solution in this particular problem. Because we were not really doing anything else later on, I'll take either one of those. The next couple have a decimal in the power, and I just want to do a quick ones to show you that it doesn't really matter if you have decimals or regular nice integers or fractions. It's always the same. Just bring the power down, then subtract 1. So just be careful. In the first one, 0.7 minus 1 is going to be negative 0.3. That's the exponent. Whereas the second one has already a negative 0.7, and you're taking away a negative 1. So together that's going to be negative 1.7 to go in the exponent. So just be careful and watch out for that. Now, example 2 has a slightly different strategy. This is where we use the constant multiple rule in this problem. And just a reminder, the constant multiple rule basically says if you have a constant, meaning a number, being multiplied by some x, by some function, then all you have to do is ignore the constant and just find the derivative of the function. So basically, take it piece by piece, ignore the number, don't make it 0 though, just ignore it, meaning write it first, and then just differentiate the letters. So looking at the first example, it says d dx of 7x to the power of 4. Notice the question here, it said find each of the following derivatives, and they're writing d dx and then 7x4. This already means we want the derivative with respect to x of that quantity. They don't give us a function and we're supposed to like introduce the derivative. They're just saying, here's 7x to the power 4, we want you to find the derivative. So as soon as I do the movement of the exponent to the front and so on, I stop writing the d dx. Until then, I keep writing it down. So first, I'm noticing that there's a number and there's some x's, and what's between them is a multiplication since there's nothing. So according to the constant multiple rule, the 7 gets ignored, and we just find the derivative with respect to x of x to the power of 4. That's all we gotta do really. So again, the 7 gets ignored because of the rule, and we turn our attention to just x to the power 4, and don't forget, there's multiplication in the middle. At this point, 7 is just hanging out, doing its own thing, and the x to the power 4 drops the 4 down, and then it loses 1 from the 4. So 4 minus 1 is the new exponent. So this is going to be 28 x to the power of 3. And that's pretty much the end. Very simple, no? So give it a shot. See if you can do part 2 of this problem. So did you end up with negative 6x squared? So again, I noticed that there's a number. So I ignore the number and I take the derivative of x cubed. And I just want to, again, point out that this derivative of x to the power of 3 is giving me the 3x to the power of 2 basically. Just like earlier, the derivative with respect to x of x to the power of 4 gives me 4x to the power of 3. So it goes away, the d dx notation goes away, and it gets replaced with the new term where you have the power in front and say, subtract 1 from the exponent. The next couple are going to be very similar, except the x here is in the denominator, so we have to do a little bit of a challenge first. We have to get the x out of the denominator. We cannot differentiate problems where x is in the bottom of the fraction. So what we have to do first, before we start looking at whether this is a constant multiple rule or whatever, is to bring the x out of the denominator. We can do that by bringing it to the numerator and making the exponent negative. So this is using what's called the negative exponent rule. The rule says a to the negative m is 1 over a to the power of m. Or vice versa. If the negative was on the bottom, then it becomes positive on top. So that's what we call the negative exponent rule that I'm using on this particular one. So this is just something from the review. This is not calculus, this is basic algebra. Now I'm noticing that there's a number multiplied by a letter with an exponent. So according to the constant multiple rule, the number gets ignored, and we just find the derivative with respect to x of the letter x to the power of negative 5. So again, exponent is going to come down in a second, and we will just multiply it with the 1/3 that's already there. So be careful, the x1 is negative. I need to put some parentheses around the -5. And then x to the power of -5, -1. Because we always take away 1 from the power. Regardless of what the power is, we always take away a -1 because of the power rule. So at this point, we're just going to multiply and add and subtract and whatever. So this is the same thing as -5 over 1. So we multiply the top with the top, the bottom with the bottom. We get -5 over 3. And x has a -6 exponent. So we can leave it like that. Or we can write that the derivative is -5 over 3 x to the power of 6. Using the same rule from the start of the problem. We can rewrite the fraction with the -5 on top and the 3x to the power of +6 on the bottom. Again, doesn't matter which one you do, they're both perfectly acceptable. So can you do the last one? Can you pause the video here and see if you can get that last one done? So again, I noticed that there's a fraction first, the 5/4, with the x6 on the denominator. So first of all, I need to get the x6 out of the denominator. So I do that by rewriting it with a negative exponent. Then I notice that there's a constant being multiplied by a function. So I just drop the constant out of the derivative and I just focus on the x's. And again, the derivative of x to the power of -6 is the -6 x to the -6 -1. Just like earlier, the derivative of x to the power of -5 was the -5 x to the power of -5 minus 1. And -6 -1 is just going to be -7, and multiplying the 5 with the 6 dividing by 4 gets us 15 over 2 with a negative sign in front of it. And again, doesn't matter where you put the x on the numerator or the denominator, they're both just perfectly fine.